Good evening, students. So I hope that you all are doing good. And I started with the substitution and elimination reactions. In this video, students, we'll be talking about, just a second, we'll be talking about substitution versus elimination. Okay, that means in which case you will think of substitution, in which case you will think of elimination. So those type of scenarios. You can simply say that this video is based on the comparative study. Okay, it is based on the comparative study. Also, whatever videos I have made in the past, students, I have made on the whiteboard, which you can see just behind me. But today I'm trying this new mode. Just let me know whether this video you liked it or not, or this mode of teaching you are enjoying or not. So you can just update me in the comment section. Okay, now just to add one thing here, just a second. Yeah. So anyways, sorry for this. Yeah. So yeah, just see now. See, I want to divide this into two steps. Like one is, that means how many steps the reaction have. Okay, like for example, if the reaction is happening in a single step, okay, if it is happening in a single step, and if it is happening in a multiple step. Okay, so when we talk about substitution and elimination, students, single step means ki either it can be substitution, or it can be elimination. Now same thing is valid for the multi-step category also. Either it will be substitution or it will be elimination. Cool? Very good, right. Now if you are talking about single step, so substitution means SN2 and elimination means E2. And if you are talking about substitution as part of multiple step reaction, so then substitution means SN1 and elimination means E1. Very simple and straightforward point, right? Okay. So after that, students, what you can see, we have certain conditions. Okay, now I'm writing all those conditions taking alkyl halide as a substrate. Okay, taking alkyl halide as a substrate. Okay, this is a very valid point, and at the same time, students, important also. Obviously, whatever is applicable for alkyl halide, it will be properties for alcohol or any other compound also. And I believe that you know that substrate means reactant. Okay, substrate means reactant. So let's say I have taken 1 degree alkyl halide. Okay, I have taken 2 degree alkyl halide, or I have taken 3 degree alkyl halide. Fine. So if I'm talking about, now I'll talk about SN2, E2, then SN1, and then E1. So if you are talking about SN2, students, SN2 mein 1 degree alkyl halide if you take, SN2 will definitely happen, right? And E2, if steric crowding is there. Okay, now keep in mind that generally in 1 degree, okay, generally in 1 degree, you have SN2 as the major product and E2 will be very minor. Okay, and even if you think of E2, that is only possible with a very strong base. So we will see it through questions. Okay, so in E2, if you are thinking of E2 as the major product, so that with 1 degree alkyl halide, obviously, so that is only applicable if you have some sort of steric crowding where SN2 will be less favored, right? Because you know that SN2 depends on steric hindrance or steric crowding as well. SN1 is a big no, students, because you know that in SN1 and E1 we have a carbocation intermediate, and 1 degree carbocation is not a good idea. So whatever is valid for SN1, same will be valid for E1 also. Why? Because in both cases it is a case of carbocation formation. 2 degree is the most confusing case. Fine. So SN2 can happen obviously, and E2 can also happen. In which case SN2 will be preferred, in which case E2 will be preferred, that we will see. But in short, I am writing with weak base, SN2 will be major product, okay? And with very strong base, E2 will be major product in 2 degree, okay? And somehow, if you have high temperature conditions, okay, if you have high temperature conditions, so that favors E2, okay, over SN2, okay? Now 2 degree alkyl halide, SN2 is not a SN1 and E1, sorry, SN1 and E1 in 2 degree is not a good idea. Similarly, if you take 3 degree, so 3 degree mein there is no SN2. Why? Because too much of steric crowding is there. E2 is possible if you are taking a strong base, and SN1 and E1 is possible with SN1 is possible with weak nucleophile, okay, and E1 is possible with a weak base. So obviously, you know, I hope I don't need to tell this, but keep this in mind in general, students, ki in organic chemistry, which I have told previously also, this is just a quick revision, ki base abstracts hydrogen, okay, base abstracts hydrogen atom, and that's why it performs elimination. Sorry for my spelling, elimination. And if nucleophile, okay, if you have a nucleophile, so then that nucleophile does what? It attacks, okay, it attacks electrophilic center. Sorry, it attacks electrophilic center. Okay, or you can also say electrophilic site, means the same thing, and that's why it causes substitution. Very basic and but important, yeah. Now I'll show you some scenarios. Let's directly target scenarios. Okay. Now let's say I have taken a 1 degree alkyl halide. Okay. And I'm taking here, let's say I'm taking here OH minus. Okay. So you can see obviously that OH minus can act as a nucleophile and it can act as a base. Now you can see if it is a 1 degree alkyl halide, students, it's a 1 degree alkyl halide because the carbon which is connected to chlorine is a 1 degree carbon. So that's why it's a 1 degree alkyl halide. I hope you know this is very basic. In alkyl halide, the degree is decided on the basis of that carbon which is directly connected to the halogen. Fine. So in that case, there are two possibilities. One is that this OH minus, okay, attacks this chlorine and this chlorine will leave. So in that case, what you get is OH here and Cl minus leaves as a leaving group. So this is which type of product, students? This is SN2 product. Why? Because in 1 degree alkyl halide, if substitution happens, it will happen by SN2, and if elimination happens, it will happen through E2. Fine. Now, if you take the same alkyl halide, students, it's a 4-carbon alkyl halide, and I'm taking here OH minus. Okay. So in that case, if you have 1 degree alkyl halide, so then if you are thinking of E2 here, what you will do? This is the alpha carbon and this is the beta carbon. So then if this beta has a hydrogen, so OH minus as a base will take this hydrogen. This hydrogen will give electron and this chlorine will leave. So then what you get will be this alkene and then obviously water and Cl minus. OH minus will take the H plus. So see, this is the E2 product. Now here you can see one thing, students, because this alkyl halide doesn't have any steric hindrance, so that's why SN2 will be the major product here. Now you can ask me that, sir, is it possible that we have a 1 degree alkyl halide but elimination product will be major? Yes, it is possible. Just see this. So just see this case. Okay. Now if you are taking same thing, let's say you are taking OH minus. Okay. Now obviously this OH minus in the question can be written as alcoholic KOH also. So if you have OH minus and it is doing, let's say, obviously it's a 1 degree halide, so SN2 or E2 will happen. So SN2 product will be this OH, okay, and E2 product will be this. Okay, so this is E2 and this is SN2. But keep in mind, here it has been seen experimentally that E2 is the major product. Why? Because if you know the stereochemistry, the nucleophile is supposed to attack from the back side if you're talking about SN2. And because there is significant steric crowding here, because you know the methyl group can be seen like this. And similarly, the second methyl group also will be something like this. So there will be significant steric crowding which will inhibit this SN2. Fine. So this point is also very important, which you have to understand and keep in mind. Fine. So you can see that E2 is a major product, and that is what, if I go back a bit and show you here, you can see that I said that 1 degree alkyl halide may E2 will be major if you have a significant steric crowding. Okay, so I hope the point is pretty clear. Now, if you come to a 2 degree case, let's say I take something like this. Suppose I take this alkyl halide. You can see it's a 2 degree halide. So what I said, in 2 degree also either SN2 will work or E2 will work. Now let's say I have taken a base like this. Okay, and here I have taken a base like this, something like this. So in this case, you can see that this negative charge is actually doing resonance, right? This is a weak base. Why? Because it's a conjugate base of carboxylic acid. So carboxylic acid is significantly acidic. So conjugate base will be weak as per the Bronsted theory. So because the first case we have taken, it is acetate ion, conjugate base of acetic acid. So this weak base will not do elimination, rather it will form this product as the substitution. That means you can say this is the SN2 and this is the major product. Okay, and in fact it has been seen the yield here is almost 100%. That means there is no scope of elimination reaction because it's a significantly weak base. Okay, so generally if you have a weak base, so then in 2 degree alkyl halide you can prefer substitution over elimination. Also, one point to add, generally at room or low temperature substitution is preferred. Okay, so that low temperature always favors substitution and high temperature favors elimination, students. But if you take a decent base like MEO minus, okay, like this is the conjugate base of methanol. So in this case, because the base is strong, so 2 degree will prefer elimination. That means this MEO minus will abstract this hydrogen. This hydrogen will give its electron and this bromine will leave from the opposite side. So what you will get will be something like this. And then obviously the side products, which are not very important, but if you want, you can show it. So then this is the E2. Okay, sorry. This is the E2 and this is obviously this is the major product. Fine. This is the major product. Okay, cool. Fine. Now, I'm taking one specific case. Just see here, students. Suppose I have something like this. So you can see this is a 3 degree halide and I have taken MEOK. Okay. Now, please understand one thing. And obviously, let's say I say heat. Now, please understand one thing. This MEOK is actually MEO minus and K plus, where MEO minus will be the nucleophile. So obviously, negatively charged entities in general can be considered as a strong base or strong nucleophile. So strong nucleophile prefers SN2, strong base prefers E2. Fine. And if you have weak nucleophile or weak base and a 3 degree halide, then they favor SN1 or E1 mechanism. Okay, so this is the overall basic idea. Fine. Now here you can see this is a 3 degree alkyl halide. I hope this point is pretty clear. This is a 3 degree alkyl halide. Tert butyl bromide, this is called. And in this, another thing which you can see, students, this is a strong nucleophile or strong base. So if it is a strong nucleophile, it will do SN2, but obviously it's a 3 degree halide. So SN2 here is a big no. So only option possible is E2 here. So we will do E2 here. That means you take, see, all these beta carbons are identical. So you can abstract hydrogen from any of this beta position. Fine. And then this will, cool, something like this. So the alkene you will get will be obviously this one. Any one you can show as double bond, something like this. So this is the E2 product. Fine. So I hope the point is pretty clear. And if we have taken a 3 degree, now you could have asked, sir, this is 3 degree, then why you are not thinking of SN1 or E1? Because the base is strong. If the base is weak or the nucleophile is weak, generally neutral charge species, or if you see molecules like water, alcohol, methanol, ethanol, so solvolysis, so then those things favors SN1 or E1. Just मान लो, if I have something like this, okay, and I have taken here water. Okay, so in general, water actually can be called as a case of solvolysis also. Now, what is solvolysis? Solvolysis is a reaction where the liquid or the solvent itself is acting as a nucleophile. Okay, that is solvolysis. And solvolysis means because water or let's say methanol or any other liquid if we take, okay, so in that case, it's considered as a weak nucleophile or weak base. Now here, just erasing this part for a while because I'm taking water as the nucleophile. So you can see here, because it's a weak nucleophile, so obviously here SN1 will happen, and whenever SN1 happens, students, E1 also happens. Fine. But in general, always consider SN as a major product. Always consider SN1 as a major product if you have a 3-degree halide and you have a weak nucleophile or weak base. But obviously, nucleophile means substitution, base means elimination. I hope that part is pretty clear. So SN1 you can consider as major and E1 is considered as minor in general. So obviously the products you will form from here, I hope it is clear. First thing first, we will remove the halogen. So you will get a cation like this after you remove Br minus from here. And obviously there is no rearrangement possible in this cation. Fine. Okay, जैसे मान लो you could have said कि sir ring expansion करो ना. If you do ring expansion, this will become a 6-member ring. But please understand one thing: if you do ring expansion here, then the cation will be 2 degree. Now it is 3 degree. So this ring expansion is not a good idea. Keep this in mind whenever you do ring expansion. Each and every step of the rearrangement should be thermodynamically profitable. Okay, so here we will not do any rearrangement, and that's why the nucleophile can directly attack here. So water will attack here as a nucleophile, and then the product you get will be something like this, students. I'm directly removing H plus. So this is the product. This is the SN1 product. Fine. And if you would have thought of E1, तो E1 अगर तुम सोचते यहाँ पे, तो जो मेजर एल्कीन तुम बनाते है ना, जैसे मान लो ये कैटायन होता और यहाँ से आप एल्कीन बनाते, तो ऑब्वियसली यहाँ से हाइड्रोजन निकालते, बिकॉज है ना, एलिमिनेशन करते, तो दिस प्रोडक्ट वुड हैव बीन मेजर ड्यू टू हाइपर कॉन्जुगेशन, है ना. बट समझ जाओ कि दिस इज द E1 प्रोडक्ट, तो दिस विल बी माइनर, ठीक है ना, and this is SN1, so this is major. So in general, whenever SN1 and E1 are competing with 3-degree halides and you have a weak base or weak nucleophile, especially when it is solvolysis, so in that case, always prefer SN1 as the major product. Okay. Now you could have asked that, sir, is there any case where E1 will be the major product? Yes. E1 will be major if they mention हाई टेम्परेचर कंडीशन. अगर ऐसा कुछ मेंशन करते हैं कि एलिवेटेड टेम्परेचर पे होगा, देन यू कैन गो फॉर E1 एज द मेजर प्रोडक्ट. हाई टेम्परेचर और क्वेश्चन में लिखा हो एलिवेटेड टेम्परेचर, तो इन सच केसेस स्टूडेंट्स यू कैन थिंक ऑफ लाइक दिस. ओके, आई होप इट इज प्रीटी इजी एंड प्रीटी क्लियर ऑल्सो. फाइन. नाउ वन थिंग आई वांट टू क्लैरिफाई हियर कि I hope now all the points are clear ki when we will think of SN1, when we will think of SN2. Okay. Now few things should be pretty clear. जैसे मान लो कि if I take anything like this, है ना, मान लो ऐसा कुछ ले लिया मैंने, अच्छे से देख लो, ये मान लो ऐसा कुछ लिया, ठीक है ना, और मैं तुमको बोलता हूँ कि let's take alcoholic NaOH. तो generally alcoholic medium में the base acts as a, that means alcoholic medium में NaOH or KOH always acts as a base. Now the question is कि whether you will remove beta hydrogen from here or here. So obviously here. Why? Because the alkene which will be formed will be more stable. अगर तुम हाइड्रोजन यहाँ से निकालते हो from the first position and let's say this is second position, तो minus beta 1 will be a better option. Why? Because जो भी आप बना रहे हो ये, तो यहाँ पे this pi bond will be in the resonance with benzene ring. तो ये आपका E2 में भी मेजर प्रोडक्ट, दिस विल बी द मेजर प्रोडक्ट. फाइन. एंड आई होप ऑब्वियसली E2 we have discussed in the previous videos also, so I'll not go in detail. But one thing I want to ask, suppose you have something like this, students. Okay, just see this. Suppose you have something like this, just a second, and here all the 3 carbon has hydrogens. Okay, showing it. Why? Because I want to emphasize on the question. Please understand here. And the third carbon also has hydrogen. Cool. So that is CH3. Basically, it is CH3 whole thrice. Fine. Okay. And the second halide I am taking is something like this. Same halogen I am taking. But what I'm doing is, these carbon has now deuteriums. I hope the question is pretty clear. Instead of taking CH3, I am taking CD3. And what is this D? This D is obviously deuterium. Fine. I hope the question is pretty clear. This is a question, obviously. Cool. This is a question. Now, what I mean here is, students, in this case, if you are treating this as this with, let's say, alcoholic KOH, and this also you are treating with alcoholic KOH, so in which case the reaction will be faster. That means, let's say here reaction takes time T1, okay, and in this case the reaction takes time T2. Fine. So in this case, what will be the relation between T1 and T2? Let's say T1 is greater than T1 is less than T2. T1 is T1 is equal to T2, and fourth one is obviously none. Or let's say the data is not enough. Okay, incomplete information, something like that you can think. Now please understand one thing. The halide which is given and the reagents you have used, they are going to perform elimination, obviously. And alcoholic KOH generally acts as a base. So in that case, what will happen? Your particular, just a second, students. Yeah. So if you think logically, okay, I'm just changing it to